Here we're going to start looking at Chapter 3, which is looking at some measures of center. So our key concepts here, the focus of this section is to obtain a value that measures the center of data. So in particular, we present measures of center including mean and median. Our objective here is not only to find the value of each measure of center, but also interpret those values. So here is a statement: men are taller than women. Is this true? That overall statement would not be true because that's just saying that men are taller than women, and not every man is taller than women. So we're going to look at some different things, different way to say this statement to make it more accurate. So suppose we collect data about heights of men and women. How should we determine if men are taller than women? So we could look at some different pieces of data. If you're collecting data, we could look at an average or a mean. We could also look at the median. So let's just take a look at some more detailed information. So suppose we can conduct a study and find that among 50 randomly selected men, the average height was 69 inches or 5'9". And among 50 randomly selected women, the average height was 64 inches or 5'4". So does this mean that all men are taller than all women? This does not. We're just looking at an average. Okay, so there could be cases where a man is shorter than a woman. This average, if you think back to what we have talked about in earlier chapters, we are going to be looking at what would be a normal distribution. So we could have really short men over here and really tall men here. We're just looking at this mean or this average that's here in the middle, where most men are going to fall. So we're going to look at each of these statements and determine if each is true or false. All men are taller than women. Well, this is definitely false because there could be cases where a man is shorter than a woman. Most men are taller than most women. That could be true because we do have that most men are taller than most women. Again, if we looked at both pieces of data from a normal curve, we're going to see more information. The average height of men is greater than the average height of women. This is a really good statement and one of the better statements to say. So that's definitely true. And typically, men are taller than women. This is also true because we're going to be talking about typical height in this case. When you're talking about a mean, you're talking about a typical number. So generally, what we're comparing is the idea of typical height difference between men and women. So for a measure of center, it is a value at the center or middle of a data set. Measures of center are often interpreted as typical values for a group. The most common measures of center are your mean, median, mode, and mid-range. Here is some notation that you're going to want to make note of. We have sigma, which denotes the sum. X denotes an individual data value. Lowercase n denotes the number of values in a sample, where an uppercase n denotes the number of values in a population. X bar is a sample mean and a mu is a population mean. So the mean of a data set is found by adding all of the values and dividing by the number of values in the set. A sample mean is going to be X bar. A population mean is going to be mu, and it is the mean of an entire population. In either case, simply add the values and divide by how many you had. In Excel, you will use equals average and then select the data set. The median of a data set is the value that is in the middle when listed in ascending order. So you're going to order the data set from smallest to largest, and then find your median. The median shows what number separates the bottom 50% of the data from the top 50%. And roughly half of all the values are below the median and half are above it. In Excel, you will use equals median and then select the data. Okay, you do want to make sure you just get in the habit of ordering those data values first from least to greatest and then finding your pieces. The mode of a data set, if it exists, is the value that occurs with the greatest frequency. A data set may have no mode, so this means that if all of the pieces of data are seen the same amount of times, there will be no mode. A data set may have multiple modes if there are multiple values tied for the most. So they would all be modes, and this would be called multimodal. Mode is the only measure of center that can be used for qualitative data. Do not use the Excel code for mode because it will fail to find multiple modes. Instead, you want to sort the data and then look for your modes manually. The mid-range for a set of data is the value that lies exactly halfway between the minimum and the maximum for that set. So your formula for a mid-range is max plus minimum divided by 2. The mid-range is very, very rarely used to describe the center of a data set. The mid-range is calculated only based on the two most extreme data values, and therefore it's highly affected by outliers. There is no Excel function for mid-range, so if you need to find the mid-range, you can type in equals, select your max value, plus, and then select your minimum value divided by 2. Do make sure that you are careful with those parentheses because it is very important for your order of operations. So here we're looking at a comparison of the measures of center. So mean, it's easy to calculate, it uses every data value, therefore it's highly affected by outliers. So you do not want to use the mean for skewed data sets. The median, a little bit harder to calculate unless you have Excel, and then it's not affected by outliers, and you can use it with any data set. The mode is not necessarily the center, it's not affected by outliers, and only really useful for multimodal or qualitative data. For mid-range, it's easy to calculate, but it is highly affected by outliers. It's not necessarily the typical value. You would want to compare the median or the mean to evaluate skewedness with the mid-range, and you generally do not use it by itself. So this is just that good comparison. Make sure you are paying attention. If the data is skewed, you cannot use the mean because it is affected by your outliers. If you have skewed data, you are going to usually be looking at your median. So let's take a look at an example. There is a file that's posted in Blackboard called Measures of Center, and you can go through and practice finding all 4 measures of center, how they're similar, how they're different from each other, which measures of center do you think would best describe the typical commute time for this class, and make sure that you do it for both data sets. Now that you have completed those first measures of center, looking at mean, median, mode, and mid-range, we're going to move into calculating a weighted mean. So a weighted mean is when different X data values are assigned different weights, or W. We can compute a weighted mean by finding the sum of all weights times your X values or your data values divided by the sum of all the weights. So we're going to take a look at this example about computing grade point average. So we have a student that in her first semester of college, she took 5 courses. Her final grades along with the number of credits for each course. So she got an A in a 3-credit course, A in a 4-credit course, a B in a 3-credit, C in a 3-credit, F in a 1-credit. And the grading system assigns grade points to letter grades as follows. So you can see A's give you 4 points, B's give you 3, C's give you 1, D's, F's, and F's 0. So here we're going to compute her grade point average. I have a video created for Excel, finding the grade point average, and it will be a separate YouTube video for you. Here is the solution written out, but again, check out that YouTube video, and that should clear up any questions that you may have here. This is how your table should end up looking once you complete it in Excel.